Hi everyone, let's solve today's daily challenge, that is maximum product of splitted binary tree. So let us see what the question is. We are given the root of a binary tree and we need to split the binary tree into two subtrees by removing one edge such that the product of the sums of the subtrees is maximized. Alright, so what does that mean? So basically what we can do is remove any of the edge. So if I remove this edge, you can see these two subtrees are created, right? So this is one tree and this is another tree. Now, what we want to do is we want to maximize the product of the sums of these subtrees. So basically what we do after splitting this edge is calculate the sum of both the subtrees. So for this one we get 11, for this one we get 10, right? And this value that we get, the product of subtree 1, sum of subtree 1 into sum of subtree 2, we want to maximize this product is what we need to maximize, right? And we need to return the maximum product of the sums of the two subtrees, right? All right, so I hope you understand the question. All right, so basically here there are multiple possibilities that we can do, right? If I remove this particular edge, then you see this is one subtree and this is the second subtree. So 4 into, if you calculate the sum for this, you will get 11 plus 5 plus 1, right? So which is 17, right? So 4 into 17 is what you get. Then if let's say I remove this edge, then you get 110 as the sum, or 11 into 10 as the product, okay? Then if I remove this particular edge, then I get this subtree and this subtree. So for this subtree, the sum is 9, and for this subtree, the sum is going to be 12, right? Then if I remove this edge, then this subtree gets created and the product will be 6 into 4, 8, and 7, right? 17. So basically this is what we get, right? So if you see what will be the maximum value out of all of these values, that is going to be this one, right? So that is what we return, that is 11 into 10. So I hope now you've understood the question. So out of all of these possibilities, we want to return what? The maximum product that we can get. Now, as you saw when I tried to, try run this particular example with you. So you could see that what we were doing was that we were removing each and every edge of this tree, calculating its sum and then multiplying it. So that would be a brute force approach, right? That would be a brute force approach. So what will you be doing in that brute force approaches? You will simply go here. So let's say we're doing a DFS traversal. So I will come to this particular node, and then what I will try to do is try to calculate the sum of this particular node by removing this, right? And so I'll do a DFS for this and calculate the sum and then multiply both of these values, and that we will do for each and every node. So we'll go and stand on each and every node and do it for them, right? Okay, so that is one brute force approach. Can we do better, right? Yes, we can do better. So first thing is, if you see, um if I calculate the sum of subtree 1, right? If I know what is the sum of subtree 1, then can I, without calculating, again doing a DFS traversal, the sum of the subtree 2? So yes, I can do that. If I know the sum of the whole tree, then I can calculate the sum of subtree 2, the subtree 2, if I know the sum of the subtree 1, right? So what I'm saying is, if I need to calculate the sum of subtree 2, then what I can do is simply have the total sum of the tree and subtract the sum of subtree 1, right? That is valid because if I have 4, so all I need to do is to calculate the sum of this tree, I need to have the total sum which includes 4 and just remove this value, right? So this is the first thing that we observe from here. So how can we optimize our solution? All right, so this is one key to do that. That is, have calculate the total sum beforehand. So what we can do is, from this brute force, if I try to optimize my approach, this is my first observation. So what I'll do is I'll do a DFS traversal and calculate the sum of the total tree, right? So total sum of the tree by doing a DFS traversal. All right. Then what can I do, right? Then I can do another DFS traversal, and I can basically mimic this and use this condition to calculate the product. So what we are basically doing is we are not having to do a DFS traversal within the DFS traversal that we will do for going to each and every node, that the brute force solution that we discussed, right? So in the brute force solution, what we were doing, we were already doing the DFS traversal, right? And within this DFS traversal, I was going to a particular node, and from there I was doing another DFS traversal for the second subtree, so that I can optimize using this condition. So now what I will do is I will simply do a DFS traversal, and I will reach to, let's say I am reaching this particular node, right? So if I'm reaching this particular node, then I would know the sum for this, and to calculate this product, I will simply have the sum of this particular subtree that I've already visited in the DFS and subtract that value from the total sum, right? So let us try to do a dry run for that. All right, so I have this particular tree, right? So let me try to create a table for that, how this DFS traversal will look like. Okay. All right. So when we will be doing the DFS traversal, obviously first we'll be going to the left side of the tree, then to the right side of the tree, and then we will be calculating the sum of that particular subtree, right? Now using this sum, we will utilize here. Let's call this sum as subtree, sum of the subtree 1, and then sum of the subtree 2, we can calculate this way, and we can simply have a, let's say, a value called max prod. So this max prod will correspond to maximum of this max prod value, comma, this sum subtree 1, which we will be calculating here in the DFS, into the value total sum minus this particular sum that we calculate, right? Now let us see how, let us see that in action. All right, so let's say this is the root of the subtree, tree 1 is the sum of, let's say, subtree, we don't even need to calculate that, sum of subtree 1 we can calculate, tree 1, and then let's calculate the product here. Okay, let me write that clearly. Okay, let me create this again. So here we have root of the subtree 1, then here we have sum of subtree 1, and then here we have product value, right? Okay, so let's do our DFS traversal. So when we will do our DFS traversal, we'll be standing here. So as I said, first it will go to the left. So first all the left side will be traversed. So we go to the left, and then from the next DFS call we go here. So we would be having 4 as the value here, right? That will be the root, and this is the only node within the subtree, so sum is going to be 4. Now also let's calculate the total sum for this tree, which is going to be 9, 11, 12, and 9, so which is 20, 21, right? So 21 minus 4 is going to be, so it will be 17 into 4 here, right? Then let's see, then the DFS will come here, so 2. So with this, yeah, the DFS will come to the right side again, right? So then we will get 5 value here. Now sum of this subtree will be 5, right? And then this will be the rest of the subtree. So let's calculate for that. So since the total sum is 21, so 21 minus 5 is going to be 16 into 5 here, right? Then if you see what will be the next value, then our next subtree will be here. So we have traversed this node. Now we would be traversing this. So the root becomes 2, and the sum becomes 4 plus 5 plus 2, right? So this is my whole subtree now. Okay, so which is 11. Now what will be the product? 11 into 10, correct? Then after traversing this, we would come to the right side. Go to the right side, you can see you will come here. Now obviously you cannot split from here, correct? So then from the right side traversal, what will be the values? you will be getting a 6 here, and the sum of this subtree is 6. So 21 minus 6 is 15. So 15 into 6 is going to be the next value. Then you have this subtree, right? Since there is no right child here, so the root will be 3, and this value will be 3 plus 6, which is 9, and it will become 9 into 12, right? All right, so that is all of the values. So using this particular DFS traversal, this is basically the try run for that. We can basically calculate the max product. Now let us see how we will be able to code this. So as you can see, I have taken two variables here, total sum and max product, and these are both global variables, and then a mod value also, since in the question it was mentioned that the value could be large, so we need to return it modulo 10 raised power 9 plus 7, right? Okay. Then you see this DFS traversal we have done basically to calculate the total sum value, right? So what all we are doing is, this is the termination state for this DFS. We're calculating the root value, then we are doing the DFS for left and right subtrees. Then here we are doing the DFS max sum, basically calculating max sum value. So what we did just here is what we are doing here. So what we are doing, a DFS traversal to calculate the max product. So again, the same condition that is there. Then from the left side, we are calculating the value that we will get. From the right side, we are calculating, and then here we are calculating the subtree sum. So subsum, this is basically SB1, sum of one subtree, right? So as you can see, max product, we are calculating max of max product, subsum, which is sum of subtree 1, into total sum minus sub 1, which is basically total sum minus this subtree sum 1, right? Which is nothing but this whole value is sum of subtree 2, correct? So both the values we are multiplying, and we are also updating our max variable here, right? Then if you see here, we are doing a DFS traversal to calculate this total sum value. Then here we are doing this DFX max sum traversal, a second DFS to calculate the max product value, and then we are simply returning the max product modulo mod, right? So I hope I was able to help you solve this question. That would be it for this video. Thank you.